All right, welcome everybody. This is our intro to covalent nomenclature. So previous to this point, we've talked about ionic bonds, ionic compounds, and how to name those compounds. Now we're going to look at covalent nomenclature, and then we'll eventually talk about what a covalent bond is and what those compounds look like. So to recap, an ionic compound is a compound between a metal and a nonmetal. It can also be or include a polyatomic ion, such as a carbonate or ammonium or nitrate. So anything with between a metal and a nonmetal or a polyatomic ion. A covalent compound consists of a bond between two or more nonmetals. And another name for a covalent compound is a molecular compound. Okay, so covalent compounds consist of nonmetals such as, a carbon and an oxygen, or a sulfur and oxygen, any elements basically that are nonmetals. All right, so the first thing we're going to do is identify which are considered covalent and which are considered ionic. So when we're looking at water, excuse me here. Water is composed of hydrogen and oxygen. All right. So when you look at your periodic table, you'll notice that hydrogen is a nonmetal and oxygen is a nonmetal. So two or more nonmetals bonded together, that makes a covalent compound. When I look at carbon dioxide, carbon is on the right side of the metalloids. It's a nonmetal. Oxygen is on the right side of the metalloids. It is also a nonmetal. So two nonmetals bonded together make a covalent compound. When I look at sodium hydroxide, sodium is Na, hydroxide is OH. So sodium is a metal, OH is a polyatomic ion. So because it has a polyatomic ion within the compound, this automatically makes it an ionic compound. And my last one here is ammonium chloride. Well, ammonium was a polyatomic ion, and chlorine is a nonmetal. But because I have a polyatomic ion, that automatically makes this an ionic compound. All right, so how do we name these types of compounds? Okay, well, in order to name these compounds, we use a Greek prefix system. And you'll see over here to the left, you've got your prefixes that represent numbers. So the number 1 has a prefix mono. Di is a prefix for 2. Tri is a prefix for 3, like a triangle. It's a shape with 3 angles. Tetra is 4. Penta has 5. The pentagon has 5 sides. Hexa, 6. Hepta, octa, nona, and deca. All right, so these prefixes here are what we're going to use to name our compounds. You look over here on the right, there are 3 rules. Our first rule says that for the first element only, I'm going to use a prefix only if there is more than one atom in the formula. Okay, we're looking at the first element only. So in the first element in a compound, if there's one, then it does not need a prefix. If there's more than one, then it does need a prefix, and I'll look at some examples. Okay, the second rule is for the second element in my compound. And the second element always needs a prefix. Always needs a prefix, and you need to add IDE to the ending of that name. And the last rule is if it is ionic, there are no prefixes. So we've already talked about how to name ionic compounds. You'll use those rules as they apply for ionic. So these rules are only for covalent compounds between a nonmetal and a nonmetal. Any compound that is between a metal and a nonmetal, or it includes a polyatomic ion, those are ionic and they do not need prefixes. All right, so let's look at some examples here. So my first example is between nitrogen and oxygen. So on your periodic tables, I want you to find nitrogen. Okay, nitrogen is the seventh element. It is to the right of the metalloids, so that makes it a nonmetal. Oxygen, I hope by now we know that oxygen is also on the right of the metalloids, and it is a nonmetal as well. So two nonmetals makes a covalent compound. So I know that this is a covalent compound, so I'm going to use my prefix system. So the first element here is nitrogen, and there's no subscript on nitrogen, so it's implied that it's a 1. If there's no number written, it's not 0, there's a 1. We just don't write the 1 because it's unnecessary, it's implied. So, according to our rules, if the first element is 1, then it does not need a prefix. So if that's the case, then we are just going to write the name of nitrogen. So we would write nitrogen. Okay. Now looking at your second element, it is oxygen, and there's no subscript written for oxygen. So it is also implied that it's a 1, but all the second elements require a subscript according to our rules. So the prefix for 1 is mono. Okay? So mono is the prefix, and then oxygen is the element, and then my rule said to add IDE. Okay? So you wouldn't pronounce this monooxygenide. You would pronounce this in a way that we would get rid of a couple things. We would get rid of the O necessarily in mono, because oxygen also has an O to start the word. So I wouldn't say monooxygen, it would just be monoxygen. So the O here would be used for mono and oxygen, so it would have double duty. And then the ending, I'm going to get rid of the the GEN, actually the YGEN, and add IDE to the end of it. So what you end up with is nitrogen monoxide, so mono oxide, I'm going to use the O twice. And then the YGEN gets replaced with the IDE. So I get nitrogen monoxide. My second element or compound here is between nitrogen and oxygen. So we know that nitrogen is a nonmetal. Oxygen is a nonmetal. Now when I look at the first element, I look at the subscript, it's a 2. So that means that there are 2 nitrogens. 2 is greater than 1, so that means that this element needs a prefix. And the prefix for 2 is di. So I add the prefix di, and then the name of the element, which is nitrogen. All right. Now the second element is oxygen. It's a nonmetal, but there's no subscript, so it's implied that it's a 1. Now all second elements need a prefix, and the prefix for 1 is mono. But just like we said up above, we don't use mono and O from oxygen. We combine the two, and the O serves like double duty. So instead of mono oxygen, it would just be MON and then O XIDE. So remember that we're losing the YGEN and replacing with IDE. So mono oxygen becomes monoxide. My third example, over to the right, is between sodium and chlorine. Sodium, if you look in your periodic tables, it's on the left of the metalloids, so that makes it a metal. Chlorine is on the right side of the metalloids. It's a nonmetal. So this is between a metal and a nonmetal. This is an ionic compound. So if it's ionic, we do not use prefixes. So we're going to use the first full name of the metal, which is sodium. And then chlorine, I'll write it down here at the bottom real quickly. Chlorine gains IDE. Now I wouldn't call this chlorinide. I would get rid of the NE or the INE and add IDE. So this becomes sodium chloride. Okay. And my last example down here is water. We recognize H2O. It's a water molecule. Water is a nonmetal. Hydrogen is a nonmetal. Oxygen is a nonmetal. When I look at my prefix, it's a 2. Okay, so a bond between two nonmetals is covalent. The prefix 2 is di. So I'm going to write dihydrogen. So the prefix and the first full name of the nonmetal. And then the same rules apply with oxygen. The prefix is mono for 1. So instead of mono, it's going to be mono plus oxygen plus IDE. That turns into monoxide. Dihydrogen monoxide. All right, so let's look at some naming for the backside. So now we're given the names and we want to write the compound. So we'll look at our first example. It says dihydrogen monoxide. Well, we kind of already did this one. There's a prefix here. So the prefix tells me that it's covalent, because covalent compounds have prefixes. So the prefix for di is 2. Hydrogen is an H. Mono means 1. And oxide is referring to oxygen. So that means I've got two hydrogens and 1 oxygen. My O disappeared. There it is. 2 hydrogens, 1 oxygen. So H, and I need to indicate how many hydrogens with the subscript. 2. And then oxygen is a 1 But because the 1 is implied, we don't have to write it. So what you really end up with is H2O. We'll erase the 1. So you get H2NO. Get our next example here. We got carbon dioxide. Okay, so the first thing you should do or try to do is to identify if there are any prefixes. And I don't see any prefixes in carbon, but I do see a prefix in the second term, dioxide. So di means that there are 2. So I know that this is a covalent compound because there's a prefix, which means there aren't any prefixes in carbon, and it's just a 1, carbon. And di means 2. Oxide is referring to oxygen. So I've got 1 carbon and 2 oxygens. So C1O2. But we don't write the 1s because the 1s are implied. So what you really end up with is CO2. Carbon dioxide. Okay. My third example down here is dinitrogen tetroxide. So I hear prefixes, I see the prefixes. So I know this is covalent. So the prefix di means 2. Nitrogen is an N. Tetra is 4, and oxide is referring to oxygen. So what this means is I've got 2 nitrogens and 4 oxygens. So when I write the formula, I get N2O4. Okay. So now let's look at some differences between covalent and ionic compounds. So the only type of compound that uses prefixes are covalent compounds. So covalent compounds use prefixes in the name of the formula. Okay, so when I look at this first example, it says NaCl sodium chloride. There are no prefixes here because this is ionic. But when I look at my next example, it's N3O2. So nitrogen is a nonmetal. Oxygen is a nonmetal. So this is a covalent compound. So the prefix for 3 is tri. The prefix for 2 is di. So tri, and the name of the element, nitrogen. And then the prefix for 2 is di, and oxygen, but remember we lose the ending and gain IDE. So this is dioxide. Trinitrogen dioxide. So covalent compounds use prefixes, and ionic compounds are the only compounds that can have their subscripts reduced. Covalent compounds cannot be reduced. Okay, so here I've got lead 4 and oxygen. So lead 4, this means that lead has a +4 charge and oxygen has a -2 charge. So lead +4 and oxygen -2. When I crisscross those charges, I bring the 2 down here and the 4 down here, and I get Pb2O4. Now, this is an ionic compound because lead is a metal, oxygen is a nonmetal, which means I can reduce these. So when I look at the 2 and the 4 here, the 2 and the 4 I can reduce by dividing by 2. So when I divide both subscripts by 2, you get PbO2. Okay, dinitrogen tetroxide. Di is a prefix, so I know this is covalent. So di is 2, nitrogen is referring to N, tetra is referring to 4, and oxide is referring to oxygen. So that means there's 2 nitrogens, 4 oxygens. So you get N2O4. Now, because this is covalent, you cannot reduce. So even though that the 2 and 4 can be divided or are divisible by 2, because it's a covalent compound, we must leave it at N2O4. And there's my compound.